multiple tests and if-else statements. Our conditions so far distinguish between two cases, true and false, and we can have a different statement go with each. So we only have a direct choice between two options. As anyone, however, who has played 20 questions knows, you can distinguish any number of further cases if you ask more questions. Each question can reduce the number of possibilities left, and then you can reduce them further and further. Now, an if-else statement contains sub-statements. You can have any sort of statement as a sub-statement, including another if or else if statement. They can be nested arbitrarily deeply. Let's try one main example for this section, trying to distinguish a letter grade from a numerical grade. And we'll suppose the cutoffs for the grades are just multiples of 10 here, as I do in my class. So let's imagine a function. You start off with a numerical score, a double we can assume, and we have a function letter grade that determines the letter grade. We can make the letter be a char. It's a character. As we often do when we want to return something, we give a variable of the right type to hold the result. We'll let letter be the letter grade we're going to return. This is a situation, of course, where there are multiple choices for the letter. We can only ask a question or state a condition that will give us partial results. If the score is greater than or equal to 90, we do know that the letter grade is A. Else, we have all the remaining possibilities. We're still left with B, C, D, or F. But that is a reduced set, and inside this else clause, we can have a further if-else statement, and the if condition here can chip away another answer. If the score is now greater than or equal to 80, when our only choices were B through F, that must mean we have a letter grade B. Else, again, if that's not the case, we're left with three choices. We can chip away another case. Greater than or equal to 70 must mean C. And then else, what's left after that with C removed as a possibility is just two cases, and we can handle that inside this else clause with an embedded traditional if-else statement, selecting one of the last two possibilities. If it's greater than or equal to D, that distinguishes the D and F. It must be a D, and the only remaining case is the F. In all cases, we set the value of letter, and this is one enormous if statement with all sorts of stuff embedded in it here, but it's over at that point. This statement is always executed. It comes after the big if statement, and so we return the value of letter that we've calculated. This is a perfectly legal way of doing this. We have braces around each of our substatements and then indent them. However, when the indented statement is an if-else statement and we have an embedded further if-else statement, we keep on indenting further and further, and if we had more cases or longer lines, we could run off the edge of the page pretty easily. This happens often enough that we have an alternate setup that we use conventionally. This accomplishes the same thing with almost exactly the same code, but laid out slightly differently. Wherever we have an if after an else, we put them on the same line, and then only indent after that the same amount we did with the else, not further than the if that we had in the previous version. The only extra actual change in the code is that after we have an if statement like this statement after the else is just a single statement, and hence it doesn't actually need braces around it. There is a block after each condition. We have it in braces to allow for multiple statements, and the body of that is indented with relation to the line with the condition. The line with the condition either may be the first one with just an if, or a later line with an else if. The final block that's indented here comes after the else, which has no condition after it. Now, one or more of these conditions could be true simultaneously, but the way this statement is set up, it is the first condition that is true that is significant. If this is the first condition true, it's the statement right after it, or the block right after it, that is executed. And that's all. The previous parts were false, and because of the else, we never get to the rest. So the way this is set up, the first true condition has its block executed after it, and you stop. It's also possible that none of the conditions, all the way through the last one, is correct. In that case, because we have this final else clause, that catches whatever's left, and its block gets executed. Hence, exactly one of these indented blocks gets executed. In this case, each one sets letter. So then this one compound if statement eventually finishes, and we go on sequentially. We always then do the return statement and return the value of letter that was set. We can test this program. It's in grade1.cs. Here we are. Let's just run it. We have a simple main function that just prompts the user for a grade and then prints out the result. Let's try it a couple of times, not all the versions here. So let's suppose that we have a grade of 83. That's going to be a B. That's what we wanted. Let's try it one more time. Let's suppose it didn't come out so well. Then we have a 55. That was the else clause. We have an F. You can check all the other grades in a similar fashion. So here is the syntax where we're going to pick away one case at a time and put further if-else after the else that we've had so far. The way this sort of a statement is set up, when some condition is true, if the first one to be true is condition 3, it would be the block after it that is run. If condition 1 was true, it would be this block and nothing else. It would be run. We'd be done. We'd never get to this else, which has everything else. And finally, if none of the conditions is true, we fall through to the final else, and the final block here is run when none of the conditions is true. As a result, exactly one of the statement blocks gets executed all the time in such a construction. There's another variation where we just leave off this else. Here's one with just one else if, going back to our suitcase weights. Let's suppose we also say that if the weight is greater than 120, you can't take the suitcase at all. It's too heavy. But if that's not the case, there is still the chance that the weight is high enough that we're going to have a charge. Else if the weight is greater than 50, we still have our charge. On the other hand, in what would come after this if, the choices that are left where we would have an else would be the weight is less than or equal to 50, and we can have, like in our early example, that there's nothing to do then, that's just fine, no charge, nothing to say, and so we don't even bother to put in the else clause. Here we are illustrating when at most one of the statement blocks can be executed, but it's possible without the final else, ending with the if here, that none of the statement blocks is executed.